Hello students, so continuing some problems on solid state physics. We first start with the problem that if the wave function of the hydrogen atom in the ground state, that is one state, is given in this fashion, what will be the average value of 1 by r squared, average value of r squared. So here this is the constant that has been given, and the charge density is minus e psi square. So the average of r square comes as 4 pi 0 to infinity r square sigma psi square r square dr. So this again comes out to be equal to 3a0 square. So this is the average value. Now the next is if the magnetization within a bar of some metal alloy is given in 1.2 into 10 power 6 amperes per meter, and if the magnetic field is 200 amperes per meter, what is the susceptibility? So using this simple relation, that is psi is equal to m by h. So this is m and this is h, so we get the value around 6000. The next problem is how to find out the permeability. So we know built by relation that I is equal to mu by mu 0 naught minus 1. So just doing simple arithmetic, this turns around to be 1.7.54, where this is the value of mu 0, 4.2 to the power minus 7. Now, according to the tight banding approximation, the energy displacement, energy dispersion relation, that is EK relation, for electrons in a one-dimensional array of atoms having lattice constant A and total length L is given as E is equal to E0 minus beta minus 2 gamma cos K alpha. So what will be then the effective mass? So this is the relation of effective mass, that is h cross square divided by d square by dk square. So using a double differentiation of E with respect to k square, we get the value a square 2 gamma cos ka, and from putting this relationship here, we get that this is h cross square a square e0 minus e plus beta. Next is a variable to the density of state. So this is again the relationship for density of states, 2 into L by 2 pi 1 by d and dk, and this is the relationship that we obtain. The next is defining the Hall coefficient. So this is the well-known relationship of Hall coefficient 1 by Ne. This is the number density, and for sodium atom, which is having a basis structure, this is the value of the lattice constant. So this is the relationship that we will be looking forward to. M by rho is equal to a cube Ne by n. This is the Avogadro's number. By putting this value, we get the value of n. So this value of n is again put in this value of Rh. So and this is the value of the Hall coefficient that we obtain. Next is if the atomic density of a solid is given in this way, this is the value and this is the resistivity, then assuming that each atom contributes one electron, what will be the relaxation time? So the well-known relationship of relaxation time, tau is equal to sigma m by Ne square, and which comes on to be 3.8 into 1 minus 14 seconds. And then the drift mobility again is mu is equal to 1 by Ne into rho. So this is the number density, electronic charge, and resistivity. So this comes around 0.0268 meters squared per mole per second. And if the effective mass, that is m star, is 1.01 into me, mass of the electron, and there is a conduction of electrical conduction activity is given in this fashion. So what will be the relaxation time, and this is the forming velocity. So from here we can get it value of the mean free path of copper, that is Vf into tau, to this value, which is the mean free path of copper. Now for a 2D electron gas, the electron density and the Fermi energy are related by this formula. N is equal to m into Ef by 2 pi h cross square, m is the mass of the electron. Now for gold, if Ef is equal to 5.54 electron volt, what will be the number density or electronic number density? This has to be found out, so we will use this simple relationship. Only thing is that this h cross square has to be replaced, so we will replace this h cross square by h by 2 pi. So this is what the final relationship that we obtain. 2 pi m by h cross square into Ef, and putting the values here, we get the number density of the electrons. Next is, if in the case of copper, if the Fermi energy is 7 electron volt, what is the Fermi momentum? So by some relationship, 2m into Ef, which comes around to be 14.28 10 power minus 25 kg meters per second, and this is the de Broglie wavelength, lambda by hp, which comes around 4.64 Armstrong. Now we need to find out the Fermi velocity. So by a simple relationship, that is half-m square is equal to E, we get the velocity relation as 2e by ep. So just putting the value of the, so the same will be case for Vf is equal to 2ef by 2pf. So just putting the values of the already obtained values, that is 7 electron volts for ef and 14.28 for pf, we get the Fermi velocity as 1.57. Not considered the units here, so this is the numerical value that is obtained. This is the main relationship. Lastly, if the electrons are treated as distinguishable particles, at what temperature will they have an average energy? Now average energy is given as 3 by 2. It's not always a 3 by 2 if it's kVt. This is the Boltzmann constant, so this is the T, so T will be automatically equal to E by kV. So this is the 5.5 into converted into joules and divided by Boltzmann constant. So this is the value of temperature that was asked for.